I'll just go ahead and read the bios of both speakers, and then we'll get started. Our first speaker is Richard Carson, who is a professor of economics at the University of California, San Diego, holds a PhD in resource economics and an MA in statistics from the University of California, Berkeley, as well as an MA in international relations from George Washington University. Professor Carson's an elected fellow of the Association of Environment and Resource Economists and the Agricultural and Applied Economics Association, and is author or editor of 8 books. Our second speaker is Chris Barrett, the Stephen B. and Janice G. Ashley Professor of Applied Economics and Management, and an International Professor of Agriculture at the Charles H. Dyson School of Applied Economics and Management at Cornell University. Professor Barrett's teaching, outreach, and research explore why unnecessary injustice continues to disfigure a rich, technologically advanced world, and what individuals and institutions can do to improve matters. And so we'll be hearing from him for the second time because he was part of the event last night as well. So I look forward to hearing more from him. But our first speaker is Richard.
So I'm going to be talking today about pollution and health effects. One of the things that economists have concentrated a lot on is the notion that there's something called an environmental Kuznets curve. That's this upside down U curve. And what the general finding is that as income goes up in a country, you go from sort of a hunter-gatherer situation with very low pollution levels to a country, say the income of China, which would be at the top of this upside down U curve, where you get the maximal pollution, and as the countries get more and more wealthy, what will tend to happen is the countries will tend to get much cleaner. Think Sweden or Norway. Well, a good way to think about what this is let's look at Los Angeles in 1975 and Shanghai in 2015. So what's interesting about these two cities is that they have roughly the same per capita income at these different time periods. And what you can see is that these cities, in terms of their air pollution, look very similar. Indeed, if you were to go to Los Angeles now, you would almost never see air pollution that looks like this. Well, does this happen automatically? And the answer is no. This isn't a causal relationship. And a question was posed yesterday. What is the role of, in some sense, moral suasion? And if you look at this relationship that economists have devoted a fair amount of attention to, it's driven by public demand. And if we were to look at China now and you were to say, who are the big proponents of fixing the air pollution problem, it actually is the mayors of the big sort of wealthy Chinese cities. The other thing that happens, the reason it's not a causal relationship, just having your income go up, is it's very dependent on the regulatory institutions and the ability to monitor. So if you were to look at a lot of the developing countries, what you would see is that you would see very good pollution control laws on the books, but you would see them not being enforced. And in lots of instances, a huge amount of corruption surrounding pollution control and who gets enforced. The other thing that makes this curve go is technology. And so you've got to really have cost-effective technology. It's also the case that it tends to hold for local rather than global pollutants. So nothing in this environmental Kuznets curve relationship suggests that you're going to fix CO2. Indeed, the Chinese are now embarking on exactly what you would think of happened in the US. You're putting big scrubbers on the power plants, which are going to clean up the sort of local air pollution without doing anything about the CO2. There's also a big component of sorting and mobility. The wealthier people are going to move to the cleaner places. And the thing I think which is really frightening to an economist is that you often lock in this path decades in advance by your technology choices. think that you're building power plants that are going to last 40 to 100 years. This is an event, this 1972 UN Conference on the Human Environment is an event that's mentioned briefly in the Pope's encyclical. It had a large amount to do with setting the stage for international cooperation on the environment. However, it did some really bad things. And the bad thing that I'm going to concentrate on here is that it set up the notion that the developing countries were better off if they got wealthier first and then cleaned up the environment later. And this was driven by the notion that the environment was a luxury good. And this, I think, in retrospect, turns out to really be bad. And this event in particular set up this notion of differentiated responsibility, which may make sense with regard to the CO2 that you put up in the air, but doesn't make any sense with regard to dealing with your own citizens. Let's think about the core problem with environmental pollutants. There are a huge number of them. If you look at the toxic chemical inventory that the U.S. Environmental Protection Agency has, it's got hundreds of chemicals. A lot of these chemicals are on the list due to studies with animals. Some have large effects, some don't have very large effects. And the problem from a policy perspective is figuring out which don't have big effects and which do have big effects. The cost of reduction is almost always overestimated by the firms. That is, the firms complain bitterly about having to reduce their pollution levels, and the costs almost always turn out, at least over sort of the medium term, to be less than first posed. But on the other hand, these costs are largely passed on to consumers. And what that means is that when there's a decision made to regulate things, we really are, we're not passing on the costs to sort of big evil companies, we're passing on the costs to the public. Economists always look at these things and say, we need to be using some type of benefit cost analysis. And there are two reasons for that. One is the more efficient the regulation, the cleaner the environment that is optimal. The second is that there's a very strong relationship between, particularly at the lower ends, between life expectancy or any sort of health measure that you want to plot and per capita income. And so inefficient regulation is in some sense looking at reducing your income, and that's going to basically feed back and have adverse impacts on the health state of a country. If we turn now to what the main focus I'm going to talk on, and that is estimating environmental health effects, why have economists gotten involved in this? And I should step back one bit here and say, economists were heavily involved initially, particularly in the Clean Air Act. Lester Lave and Eugene Seskin had a book out from Resources for the Future in the 70s, which played a big role in the air pollution, I should say, late 60s, played a big role in the regulation of air pollution. And that's because if you simply regress death rates or rates of various respiratory diseases such as lung cancer on air pollution in the old days when air pollution levels were really high in the US, it was easy to get a relationship. About the only thing that was quite as good in terms of consistently generating adverse impacts was smoking. That's how strong the air pollution effect is. But the traditional toxicology measures, which are used for most of the toxic chemicals, don't really work that well because, for some of the things we're going to talk about, because you can't experiment on people, and the levels that people are facing are generally a lot smaller. The traditional epidemiology approaches also have problems. They're good at two things. They're good at the traditional cholera example, or read in Ebola, recently in Africa to sort of trace back the spread of a disease, or they're really good where you have long sort of panel time series data. What are economists good at? Economists are good at showing causality. Economists have gotten particularly good at what Michael Greenstone mentioned yesterday, these quasi-experiments where there's some change and some people get the change and other people don't get the change. And I'm not going to get into the technical part of that, but the breakthrough paper here was one that Che and Greenstone had in the Quarterly Journal of Economics a little over a decade ago. And they dealt with the issue of infant mortality, which had caused the epidemiologist a lot of concern in not being able to estimate this effect. And what Che and Greenstone realized was that there was actually a natural experiment out there. The government had, in the Clean Air Act, set up this sort of sharp threshold where you were either conforming with the law in the sense that your pollution levels were sufficiently low that they didn't regulate you anymore, or you had so-called non-attainment areas where the government came in and insisted on much tighter standards to try to reduce the air pollution. And there were cities on both ends of that line, and it's easy to compare those cities. The other thing that Che and Greenstone realized was that air pollution goes up and down in times of recession. And you can use both of these changes to sort of tease out what the effect on infant mortality is. And in this case, the effect they found was fairly large and very convincing. And this is now sort of a robust finding that air pollution levels, in particular particulates and carbon monoxide, tend to drive infant mortality. Let me talk for just a minute about a study that I did on arsenic in rural Bangladesh, which is going to turn out to be a very sad case, but one which economics provides an interesting answer of. So what happened in Bangladesh? They drilled 9 million shallow tube wells. These are about 30 feet in depth. This was the favorite aid project of lots of organizations like Oxfam. It did marvelous things initially because what happened? You replaced surface water with the groundwater, you got rid of the biological contamination. Women walked long distances to carry the water. And the technology to put in these wells was not large, and so it could be replicated. Well, unfortunately, what they did was that they exposed 50 to 70 million people to sizable concentrations of arsenic. The World Health Organization called this the largest mass poisoning in history. And after they discovered this problem, the public health community and some economists concentrated on two things. One was getting the exposure levels down. In the US, you could go into a hospital and they could put lots of stuff in you that would sort of absorb the arsenic, but this isn't going to happen in Bangladesh. The main thing that you could do was stop the consumption, and what they did was they went through and they tested the wells, and they painted the wells green if the wells were safe, and they painted the wells red if they had too much arsenic in it. So the public health folks concentrated on estimating the long-term health effects. And so the long-term health effects are arsenic causes lots of different types of skin cancer, and arsenic destroys all of your internal organs. And so this is a pretty ugly way to go. With two European economists, we asked a different question. We said, what should the medium-term effects be? Well, if you've ever seen movies like Arsenic and Old Lace and whatever, you see that the immediate effects are that people slow down. They become lethargic. In this case, they get headaches. They become dizzy. They get sores on their hands and feet, which are the precursors of this later skin cancer. And if you think about all those things, what should those do? That should make it harder for people to work. We matched data from the Bangladesh equivalent to the US current population survey, which had detailed information on how much people worked. The British Geological Survey did a large-scale random sampling of wells in Bangladesh. It turned out there were wells, you could have two wells that were, a couple miles apart. One would be clean, one would be not clean. We matched the data from the period immediately before this became known to the public. So, fortunately, from a statistical standpoint, this is about as clean of an event as you can get. Nobody knew the arsenic was there. Nobody was responding to the arsenic. It took about 10, 15 years for these symptoms to develop. So what did we find? We found that Bangladesh had lost about 8% of its labor force hours. Now, to put that in perspective, that's larger than the increase in the US during our immediate past recession, the global financial crisis. The households didn't appear to have lost as much income because there was a lot of substitution within households of who worked there. Since this is a religious organization is sponsoring this, there are actually interesting religious effects within the household between Islamic and non-Islamic households. There are interactions of the arsenic contamination with education, land holdings. So this is a pretty big effect. And the interesting thing is that people didn't recognize that it was there. If we characterize environmental health effects in general, I'm going to run quickly through a few categories. One is specific diseases, and that's where environmental epidemiology and economists started. Once people started to see these effects, they backed up and said, what are the effects on economic growth? Recent work has focused on different stages of life and on different types of activities. I'm going to briefly mention defensive and avoidance behavior, which in a lot of cases is fairly large, and then I'm going to end talking briefly about climate change. Well, in terms of specific diseases, some of these have been recognized for a long time. King Edward I of Great Britain, back in 1306, made burning soft sea coal a capital offense for which you could get hung. Anyway, the people in London were cold. This was pretty ineffective. His successors tried to do this until James I, who was from Scotland, where they were importing a lot of the coal, changed the law so they could burn even more and kill even more people. Anyway, this came to a head in what was called the Great Smoke, or sometimes the Great Fog. And 1952, 4,000 people dropped dead on the streets. In a fairly short period of time, 100,000 people were ill. Later estimates had put the number of deaths due to this event at about 12,000. This was repeated in a few places in the US, not quite as dramatically. The estimates from China now are really frightening. There's some debate over the exact number, but it looks like China's killing off somewhere between 500,000 and 2 million of its citizens with air pollution every year. So it's a lot of people. You can get really sort of subtle effects. Wolfram Slinker and Walker have a paper that just came out that looks at what happens to carbon monoxide. Airplanes generate lots of carbon monoxide. And to show you sort of how clever economists are, so what did they do in this paper? They recognized that bad weather on the East Coast and the Midwest had impacts on how many planes made it into LA and how long they sat there on the taxiway generating carbon monoxide. And what happens is that the carbon monoxide is a very local pollutant, and the areas around LAX and the other California airports, those areas generate more or less hospital and clinic emissions depending on the carbon monoxide levels in a way which is surprisingly large. There's lots of stuff that's done on toxic chemicals and pesticides that are tied to specific diseases. And anyway, there are papers on China that suggest that if the municipal water, which is has a lot of problems, if the water pollution levels go up, then the cancers from those chemicals, which are known from the animal studies, tend to go up. And the effects are fairly big. If we turn now to the growth of cities, there's a fascinating paper which is now pretty well accepted by David Cutler. And what they show is that the US had this enormous productivity growth in the early part of the 1900s, and that a large part of that growth can be attributed to fixing what was known as the urban death penalty. People died in the urban areas at a much higher rate. And what do they exploit there? They exploit the fact that different cities put in water filtration plants, water chlorination plants, sewage treatment plants at different points in time, and typically 2 to 5 years after this was done, the cities tend to take off. And so this is a little graph which just shows Pittsburgh, which is quite striking. This is typhoid fever, which used to kill large numbers of people in US cities. As soon as they put in the filtration plant, levels dropped tremendously. And when they put in chlorination, they continued to drop. You can say, well, does this happen in developing countries? And there have been efforts to look at this in developing countries, and the effects aren't nearly as large as they appear to be in the US. And why is that? The wealthy people in developing countries have largely isolated themselves from the water pollution problems that faced US cities early in the 1900s. They're on separate water treatment plants, oftentimes sewage systems. The other thing is that the sort of middle class in the developing countries has access to antibiotics, and antibiotics kill off lots of the biological sort of diseases. So who suffers continually in the developing countries are the poor, who don't either have access to their own water systems and don't have access to the antibiotics. There is this strong relationship between temperature and the level of GDP in different countries. This is from a paper by John Horowitz. Jeff Hill is going to be talking to you later, has done a huge amount of work on temperature. The only thing I would say here is that the US, which looks like an outlier, why is it an outlier? Well, this is the capital city in every country. Washington, D.C. used to get tropical hazardous duty pay, but where is the economic sort of center of the US? It turns out that it's about Chicago, which is cooler. I'm going to put in one plug for this, and Mark Jacobson, who's going to talk to you later, is here and is going to talk on this topic. What you see is that the leaders of a lot of the developing countries, China and in particular India, have argued against cutting their CO2 emissions on the belief that they will slow growth. This is what the studies in the US would suggest. And this is where I think I would really disagree with the encyclical. There's all sorts of good reasons that if you look at, say, putting on a carbon tax in developing countries, that you would have a positive effect on growth. And why is that? The developing country, say China or India in this case, gets to keep the tax money. You could do this in a revenue neutral way by reducing various taxes on businesses or consumption. And if you look at the characteristic of a lot of developing countries relative to the US or Europe, what do you see? You see a few characteristics of the tax system which really matter. You see lots of tax evasion. It turns out that carbon taxes are very hard to evade. You put them on petroleum refining plants and electricity. It also turns out these countries have a large informal sector. Putting on carbon taxes will shift activity from the informal sector to the formal sector, particularly if you reduce the business taxes. It's sort of well known if you want to look at the black market economy in a country. The Economist runs this periodically. You look at the ratio of electricity to GDP to see how much of it's missing. And the other thing you need, which is true of both China and India, is that you need coal deposits or some type of fossil fuel that can't get up and walk away. Let me turn now to in utero exposure. This was the Che and Greenstone example. Economists, once they saw what you could do here, have come up with lots of clever sort of ways to tease out this effect. Janet Curie and various co-authors looked at places in California where you replaced the toll booths on toll roads with easy passes. And so what that meant was that the cars weren't standing at the toll plazas anymore. And in the areas, again, and this is carbon monoxide, the areas around where the toll plazas were reduced their rate of premature births by over 10%, just by having the cars not stand at the toll plazas. You can look at the impact of various particulates, carbon monoxide, whatever, on test scores, and the in utero exposure will predict later test scores in 4th and 8th grade, which that's a sort of frightening sort of notion. And in fact, the effects seem even more durable in the particulate exposure during pregnancy will predict future salaries. And they tease these out in some ways. I could look at the study in Chile, and what makes this go in terms of the statistics is that they've got lots of different years. In some years, there's rain, which rain is really great for washing the particulates out of your sky. So there's some years where there are a lot of particulates, particularly in the later parts of pregnancy, and some years for which there's a lot more. There are a lot of childhood effects too. Janet Curie, again, has been one of the more prolific authors in this area. She shows that carbon monoxide is associated with absentee rates in Texas schools. If you want to get your test scores up, you should know in California that they fall as the particulate 2.5 micron indicators go up. Again, this is a robust finding now that's been demonstrated in a number of places. A recent study shows this in Israel. You can look at admissions for children, and you find this again in California as ozone levels go up. And one of the earliest studies on this looked at the closure of a steel mill due to a labor strike. And you wouldn't think, what's going to happen during the labor strike? Anyway, the labor strike, the air pollution levels went up, but the school absences went down, hospital admission rates went down, and mortality rates among children went down. We also have lots of studies now looking at labor market outcomes. And I think the thing to think about here is that these pollution levels that people are facing look like a hidden tax. And I think that's why economists are so apt to think about taxing the pollution to offset the sort of negative externality. Hannah and Olivia have a recent study that just got published that looks at sulfur dioxide emissions with the closure of a Mexico City oil refinery that was in the middle of the city. And on average, and this is averaged over hundreds of thousands of people who live in reasonably close proximity, the number of hours worked per week goes up by 1.3 hours. Josh Graf-Siffin and Matt Dodell look at farm workers in California who are picking strawberries and other types of crops, and they get paid piecework, by the flat that they pick. And there's a temperature effect that they take out. But anyways, you decrease ozone rates holding temperature constant by a reasonably small amount of ozone. Farm worker productivity goes up by about 5%. There's another recent study that looks at people who pack baskets of Harry and David pears, so these baskets that are given away. And it turns out that, I mean, these people don't get paid by the piece, but the number of baskets they pack actually goes up and down. And this is they look at a place called Ukiah, California, which is about 2.5 hours north of the San Francisco Bay Area. And it typically has almost perfect air quality because there's nothing really there. Every so often, this air pollution blows in from the Bay Area. And anyway, that's when the number of baskets packed goes down. And of course, people are completely unaware of this. There are now some recent studies that look at Indian garment factories. So you've got these assembly lines, and what happens there is that the number of garments coming off the assembly lines go up and down with the particulate levels. And you can show that there's local adaptation there. If the garment particular assembly line has a supervisor from the area, what happens is that they tend to recognize that the people have slowed down and reallocate people on the assembly line so as to overcome some of the productivity effects by avoiding bottlenecks. There's lots of avoidance behavior out there. So we have a lot of people buying bottled water. You can show that the bottled water, if it's in the US, consumption is sensitive to these notices that your local water company sends out, and they're sensitive in developing countries and elsewhere to biological contamination. We saw in Michael Greenstone's presentation these ubiquitous face masks that are common in places with high air pollution. You also see behavioral responses around the world in terms of water quality. At beaches, you see responses in the US of all these fish advisories of not eating them because of mercury and other contamination. We've got smog alerts, which cause people to change their behavior. And the biggie is that we've really got a lot of sorting going on out there in terms of air pollution. There's a continual sort of, Los Angeles is the great sort of example. You can take the typical, say, 3-bedroom, single family, 2,000 square foot house, and statistically move it from an area with bad air pollution to one with really good air pollution. And what will you see? Well, the price of the house will change by almost $100,000. And anyway, these effects there's studies that looked at Russia, and anyway, these effects are out there everywhere. So what's happening? The pollution levels that people are facing are influencing the really big decisions that people are making. It's also the case that proximity, and this is something that's not quite as recognized in the environmental justice literature, there's proximity to lots of undesirable facilities, be they airports, which actually noise level at most airports in the US has been going down, various toxic facilities. As you clean those up, you get this residential sorting pattern. So if you get rid of a lot of the noise at the airports, what happens? The property close to the airport, where the noise reductions occurred, is now more valuable, and you get the poor people being pushed out and being settled now by people with more income. Crime rates are an interesting one. So I'll take the second paper first. Jessica Reyes has a paper out there which shows that a a large factor in the decline in crime in the U.S. was driven by reductions in lead in gasoline. And the neurology studies, the toxicology studies, when you get these mice, the mice actually get aggressive and impulsive. It's thought in people this leads to ADHD, and in people it clearly leads to lower IQ. But what happened? Lead's pretty heavy, it settles out. So you can look at the traffic patterns and predict where the lead was, and different cities phased out their lead at different points in time. Different states essentially got rid of lead in gasoline at slightly different times. And having seen that result, and this lead result has now been replicated with bigger or smaller effects, you can go back even further and you can say in the history of a lot of US cities, they had to put in big pipes. And they had a choice of putting in iron pipes or lead pipes, and they made that choice largely based on cost, which was largely based on proximity to either an iron or a lead smelter. And the cities that chose lead pipes had much higher homicide rates. And again, these are effects that were largely sort of unnoticed. You have natural disasters. You can show that, say, Indonesian forest fires, which are thought to be due to climate change, at least in part cause an increase in childhood mortality when they occur. You can show that how much damage is done by hurricanes is strongly influenced by the size of wetland buffers. If we turn now to climate change, since I'm out of time, what you see is that a lot of the disease vectors are climate sensitive. So there's, in the US, a lot of the work's been done on Lyme disease. That's one of the main things that will spread. In developing countries, the big thing that's been looked at is malaria. Michael Greenstone has out another paper. It's well known that extreme heat and extreme cold kills. What you can show in the US is that effect has steadily been getting less over time, and that's largely due to first off, we've got heating, and as time progressed in the US, we've ameliorated almost all the sort of temperature effects with air conditioning. Well, what do we know about the developing world? They're going to get hot. We just had a heat wave in India, which killed a large number of people. These people do not have air conditioning, and that's going to make for a bad situation as temperatures go up. In the US, you can show that labor force hours and outdoor recreation declines with hot temperatures. You also know that crime is highly sensitive to temperatures. Crime goes up as temperatures go up. So there's forecast that the projected climate change will substantially increase US crime rates. You take the projections from the climate models and you just feed these through the models that show how crime is related to temperature. And the last one, there's been a lot of work, some of it quite controversial, that looks at what happens in terms of internal conflict, violence such as civil war and large-scale migration is pretty convincingly linked now to various climatological change. And I will end there.
Next up is Chris Barrett.
Thank you, Andy, and thank you all for bearing with hearing me a second time at this event. I appreciate being invited and especially getting to join Richard on a panel as a longtime admirer of his work. I think you saw why. That's a brilliant summary we just heard. I'm going to talk about a related issue of how the vulnerable, the world's poor, are affected by different forms of natural resource degradation. But I'm going to look at very different populations, and I'm going to try to make a couple of very different points, not contradicting what Richard said, but augmenting what he said. And I'm going to base all this around a long-standing economic concept, a term that's tossed around a fair amount, but often used pretty loosely, the concept of a poverty trap. A poverty trap is an equilibrium. It's a condition that exists when people are poor and their behaviors reinforce their poverty. And I emphasize the reinforcement part because much of the conversation about the poor and the environment makes it seem as if the poor are just passive victims. But it's very important to recognize that in some places, and for some forms of environmental degradation, the poor are both victims and the agents of environmental degradation. And that's not meant to blame them. It's meant to recognize that the process of resource degradation is, in many cases, an optimal response from people who are struggling simply to take care of their families. And I'm going to go through and just explain a few of the settings in which I work where we see examples of these resource degradation poverty traps. Now, let me briefly explain what I mean by a poverty trap and illustrate it with a somewhat stylized example. So assume for the moment that you have people who have land and labor, and their labor is relatively unproductive and their land is relatively unproductive. It follows pretty directly that they're going to be relatively poor, that they're going to have low incomes. And what does having low income mean? It means that they're going to consume a relatively poor quality diet. It also means they're going to be relatively unlikely to invest in soil or water conservation, much less in rehabilitating or enhancing the natural resources in their area. Indeed, they will have strong inducements to tap natural resources, to, if you will, rebalance their portfolios, to mine soil nutrients, to turn it into food, to feed their children so that they can sustain the human capital of their household by depleting the natural capital to which their household has access. So poverty, in a sense, generates hunger and natural resource degradation simultaneously, but someone who is hungry or poisoned by pollution, as Richard nicely illustrated, covering a range of excellent studies, they become less productive. They can't work as hard. They're more lethargic. They're much more likely to suffer injuries or illness that keep them out of work. And land, for example, where the soils have been mined of crucial nutrients, that land is less productive. So we have a feedback loop where their behaviors now generate the very low productivity that causes their poverty, and hence you have a very distressing equilibrium. So these sorts of poverty traps, I claim, are very real, at least very real in the settings in which I work. They're certainly not a universal condition. But understanding them and understanding what we can do to intervene to help liberate people, liberate poor rural peoples typically, from these sorts of natural resource degradation-linked poverty traps is, I would argue, a moral challenge of the first order, but also a major intellectual challenge, because it's not self-evident what we do. It's not even self-evident how we can establish really rigorously the existence of these poverty traps. But I'll give you some examples. First, it's going to be important to understand that there are a lot of different ways in which a poverty trap can arise. And let me just walk you through a couple of stylized ones. So first is you can have a unique dynamic equilibrium, by which I mean, in like somewhat non-technical terms, everybody in a community, just the technologies and the markets available to them, the natural resource base on which they subsist, just doesn't really give them the option to live the standard of living that you and I enjoy. And I think here in particular of many areas in the highlands of Ethiopia where hillsides are denuded, soil nutrients are depleted, there's no irrigation, they don't have infrastructure enough to have the option of a call center job or working in a factory. So they're just sort of stuck. Everybody in those communities is pretty poor. A second is something we economists sometimes refer to as conditional convergence. And that's the idea that not everybody is destined to be poor, but people really can't choose which path they're on. And the classic examples here revolve around, for example, scheduled castes and scheduled tribes in India, where social conventions trap them in particular forms of behavior, exclude them from the more remunerative livelihood options that exist, And you see people who are on a trajectory to be non-poor and who can robustly weather various sorts of shocks that hit them and remain non-poor in the face of adverse events. But there's a whole subpopulation around them that is just trapped in chronic poverty. I'm going to illustrate these empirically in just a few minutes. And then finally, and perhaps most interestingly, are what many of us refer to as multiple equilibrial systems. Ones where the initial condition really matters. If you start poor, your behaviors wind up trapping you in poverty. If otherwise identical people just get a bit more, they're able to change their behaviors and grow themselves out of poverty. And I'm going to talk about this example in particular in the context of herders in dry lands in East Africa, which I've been studying quite a bit. So let me just illustrate graphically what those ideas were. So if this is the sort of very simplistic graphic that we economists who work on these things sometimes use, the horizontal axis is just meant to represent some measure of well-being, be it income, be it the body mass index of a population of individuals, the asset holdings, whatever you like as a measure of well-being. The vertical axis is just that same measure at some point in the future. So this is just mapping today's state into tomorrow's state. And the solid 45-degree line there is where those values are exactly equal. So those would be dynamic equilibria. So this is a graph. The black curve simply shows a growth path, the path dynamics, if you will, of this sort of a system where you see that if you start off very poor, this curve has gotten displaced somehow on the slide, but the curve, if you start very poor, you would grow up to an equilibrium at this point, W2, which is beneath the poverty line. So people in this sort of system can enjoy income growth if they start very poor, but it's never going to get them to a desirable standard of living. And we have a range of empirical studies now that demonstrate these sorts of phenomena really do exist. I mentioned the study by Stephen Smith and one of his co-authors in Highland, Ethiopia. Felix Nashold has a similar study in India that show that there are lots of remote rural communities where this sort of dynamic really exists. Martin Revalian has a very nice study a number of years ago in China on geographic poverty traps. Remote rural locations where the infrastructure and the natural resource endowments essentially condemn the entire population in an area to a pretty low standard of living. The second case that I mentioned, what we sometimes refer to as conditional convergence, we've got people who are just sorted into groups and they can't change those groups. So you're born into a scheduled caste in rural India, you're precluded from accessing more attractive salaried employment, especially. You can't get a job as a skilled worker in a factory or in a government agency. And as Felix Nashold again in some other work has shown, that you find that you can very quickly tease out of the data tracking people over time that they sort into two very different dynamics, one of which leaves them poor indefinitely, while their neighbors, just born into a different group, are able to climb out of poverty. The third and more interesting, more complicated case that I'm going to use in the cases I'm going to illustrate empirically in just a moment is this idea of nonlinear and multiple equilibrial path dynamics, where if you start off at a very low level of living, of standards of living, you almost inevitably will grow a bit, but you can be stuck. But if you just give people a bit of a nudge, so a poor family that suddenly has access to free education for its children so that children can become literate, that enables them to move into a different zone where they may be poor sometimes, non-poor other times, because they can find work because they're literate, but it still isn't going to let them be secure the way you and I are. So this is a system in which there are lots of tipping points. And this is an entry point then for understanding links to conservation biology and ecology. So ecology, at least since Buzz Holling's celebrated 1973 paper on tipping points in ecological resilience, ecologists have used these exact same concepts to understand the resilience of natural ecosystems. Think of a lake that gets perturbed by a heavy rainfall that causes a significant landslide suddenly increases lake turbidity. The turbidity in the lake kills off a lot of fish species and suppresses the sunlight that passes through to the lake to chlorophyll production in plant species in the lake, and suddenly the ecosystem is significantly shocked. What allows that lake to restore to its initial condition, the initial functional relationships between the organisms in that lake? That's the sort of question that Buzz Holling was asking, and that ecologists have been pursuing for a good 40 years now, studying lakes, studying forests, studying the relationships between prey and predators and wildlife systems. The same basic mathematics, the ordinary differential equation-based mathematics of dynamical systems that ecologists work with, and Jeff Heel is here with us and will speak later. He's done quite a lot of important work in this area. But those basic mathematics apply as well to understanding human systems, not just the natural system, but these are the same phenomena we see in those sort of multiple equilibrial poverty traps, that there may be tipping points. They're very hard to identify empirically, but that doesn't mean that they don't exist. But there are a couple of very important differences in the framing of the problem. You see her cover photo from a PNAS special feature on biodiversity, conservation, and poverty traps that Partha Dasgupta and a very talented reproductive biologist, wildlife vet, Alex Travis, and I co-edited a couple of years ago. One of the things we emphasize in that special feature of PNAS is that when we apply these methods in thinking about natural systems, you very rarely worry about an individual fish. You don't name a particular trout. You care about whether a whole family is threatened, whether a species is threatened. You care about the functional relationships between broad groups, but we typically don't think about the intrinsic rights of an individual member of a particular species. That is different from thinking about social science, where we believe that every individual has some basic rights. So the survival of individuals is intrinsically important. They're not perfectly substitutable for one another. We are not comfortable with the idea that as long as a critical mass of Chinese remain in cities, everything's fine. China's population is not going to zero. There's no extinction of Chinese. We're worried because lots of individual Chinese lives are threatened by pollution. This is a really important, subtle, but very important difference in how we think about using these techniques in economics and social science. And the second crucial feature is the agency of the individuals, which I will come back to again in a moment, that individuals who are threatened in these systems also become agents of destruction of these systems. And so the intrinsic importance of understanding individual behavior and individual well-being separates what the ecologists do with these sorts of ordinary differential equation-based systems from what we economists do with them. So now let me go through two examples with you. That's just meant as background, so you have some idea of what the kind of basic theory and conceptualization is, background. So pastoralists in East Africa, herders, extensive herders, such as these camel herders, these Gabra herders in the Chalbi Desert in northern Kenya, they survive in a very harsh environment. About 2/3 of Africa is arid or semi-arid, and it's relatively sparsely populated. There are only about 20 million pastoralists especially in East and Southern Africa, and they rely heavily on extensive grazing because look at this landscape. You're not going to grow a whole lot of corn out there. You don't see telephone and electricity wire, so you don't have a whole lot of options for a call center employment or to work in the local steel mill. You make your living or you die by the productivity of your animals, and you select species appropriate to the particular ecological niche you occupy. In a desert, you're commonly going with camels or maybe goats. These systems are highly adapted to climate. So the pastoralists are incredibly clever at how they exploit spatiotemporal variation in water and forage availability. They move their herds long distances because they can find patches of grass and pockets of water that will sustain their herd's productivity, and they manage those systems fairly sustainably when conditions permit. But they're very vulnerable to severe drought events. What we find over and over is when a severe drought hits, when you just get a season with insufficient rainfall. The Chalbi Desert here, average annual rainfall is only around 250 millimeters. This is a really dry setting. And in there was a 15-month period my group was studying where we literally saw no rain, 15 months with not a drop of rainfall in the Chalbi Desert. That's a tough year. People lose 40% of their herd in a year like that. And that causes massive humanitarian problems, but it also causes environmental problems. The problem originates because you see multiple equilibria that arise in herd sizes. So the graphic here is a reproduction from a paper a few of us published a few years ago using 17 years of herd history data from Ethiopian pastoralists, people in southern Ethiopia, where you see the picture on the top there. And what you should take away from the graphic is that's a similar sort of plot, today's herd size, literally in logarithms of herd size, on the bottom axis, and future herd size, either 1 or 10 years ahead on the vertical axis, that there's a tipping point, that when you have 10 to 15 head of cattle equivalent, then you can typically migrate and you can typically weather a shock like a drought. And the reason for that is pretty straightforward. To migrate a herd, oftentimes hundreds of kilometers, you have to be reasonably physically vigorous. And most families have either young children or elderly or infirm individuals who simply can't make a trek like that. So in order to take care of all members of a family, you have to be able to split your herd. And you have to be able to leave a lactating animal with the people left behind in a base camp, and you have to be able to take lactating animals with those who are migrating, typically the able-bodied men. Worst case, you don't have enough lactating animals, it's a bad enough year where they all go dry, they nick the neck and they drink blood to sustain themselves while they trek. But you have to be able to split your herd. If you don't have a big enough herd, you can't split it and have both groups survive off of this. So a critical mass of herd size is essential to being able to pursue what we economists would think of as a different technology, a migratory technology of livestock raising as opposed to a sedentarized technology of livestock raising. This has been borne out in other studies that find exactly that sort of tipping point for herd migrations. So what are the implications of that? Well, if you can continue to migrate, you can move your herds across the landscape and never degrade any of the landscape, because there's a massive amount of land out there. I told you 2/3 of Africa is arid and semi-arid. It only has about 20 million pastoralists in it. The vast majority of rangelands are not degraded. But if you can't migrate, you have to stay pretty close to home. And if you're weakened by malnutrition and you can't move far from your base camp, animals very quickly concentrate in one location, and we see very tangible signs of overgrazing. If you fly over northern Kenya, you will see these donuts of degraded landscapes around permanent wells and around residential areas, small encampments, permanent encampments, where the rangeland is very heavily degraded, but that also means the animals become very unproductive. So once you tip into this sedentarized state, very quickly you have a hard time sustaining more than an equilibrium of one cow. These results have been replicated in multiple data sets from several different places in this same broad system in the Greater Horn of Africa. And it's a really distressing set of findings, because what it implies is that when weather changes and you get just a bad shock, or you wind up finding that small arms which have come into this area, people get raided and they lose a big chunk of their herd, or you suddenly start having problems with wildlife predators, lions in particular, taking out stock, some shock happens and people now are compelled to living in small, relatively grim rangeland towns. These areas are very unusual relative to other rural areas of the developing world, in that the nutritional status of children is appreciably worse in towns than it is out in the countryside, because those who live in these small towns are stuck there because their herd sizes have collapsed and they're routinely degrading the local landscape to try to sustain what little herd they've got. And their children suffer from this. Their children can't stay in school, they can't wind up getting jobs, and so they fall into exactly the same livelihood pattern. That's the sense in which it's a self-reinforcing system, that people choose behaviors that just reinforce their poverty. That's not to blame them for the situation, but it's just meant to recognize that the degradation of these areas is partly due to the agency of individuals struggling to survive. There are things we can do about that. One of the big challenges we face, so yeah, here's an example of a well-nourished family actually on the move. This is literally all their belongings are packed up on the back of that camel, and they're displacing to a different place. One of the things that's distressing is climate change in this system poses a very real risk. We collected, one of my former graduate students as part of his dissertation research, collected some rather unusual data in which we went and we asked herders to project what herd sizes they would hold. We randomly assigned them to a hypothetical herd size, but in a system in which people have been living, herding all their lives, and they see lots of other people, they have a pretty good sense of how this all works. So we tell them, if you had a herd size of X, what would you expect your herd size to be next year, and what do you think the grazing conditions are going to be like? What's the upcoming season going to be like, good, bad? And we could unpack the weather conditional expected herd growths that way. By randomly assigning an initial herd size, eliciting what people's beliefs about the season would be, we could unpack what they expected growth to be like. And what you see here are two plots that show you on the right what happens in a good or normal rainfall system, a good or normal rainfall season. And not surprisingly, everybody expects to be able to grow their herd. You know, they're herders after all. They know how to do this if conditions are good. And there's actually not a great deal of dispersion around this very simple non-parametric regression, that everybody is going to grow their herd pretty much in as a linear function of their initial herd size. There's a pretty constant growth rate there. But in a bad state of nature, in a drought year, the left-hand side graphic, you find the dispersion is huge. And you find that on average, really big herds are going to collapse. That's that relatively horizontal tail on the right of that graphic. And at lower levels, the lines cross back and forth all the time. We can blend these state conditional dynamics using historical rainfall data, and it turns out we can almost perfectly recreate that past herd history dynamics I showed you previously. So people seem to really understand what the herd histories tell them about likely states of nature over time and what its effect on herd emergence is. The problem is if we start drawing differently, we start drawing more frequent droughts, which the climate scientists tell us is quite possible in this setting. And what we see then, this is a paper from a couple of years ago, what we see then is the system right now that seems to have these multiple equilibria. If we double the drought frequency from about 6.3%, which is the current range over the 20 years we're using, if you double that to just under 13%, the resulting herd dynamics, if you change nothing else, mean that the system collapses in its entirety. There's no high-level equilibrium left in expectation. Conversely, if we were able to have or cut by a third the drought frequency, the poverty trap would be extinguished. If we could just get more reliable rainfall, less frequent drought, people would have enough time to recover their herds, grow out of the poverty that sedentarizes them. So we see a system right now that is very unstable and can be driven entirely by climate that is not determined by pastoralists in East Africa, obviously. So this is an exogenous forcing factor that comes out of the West. But it's a really troubling implication, because if we do nothing in the current system, which is adapted over centuries, climate change is much quicker. We have a real risk of driving an entire population into a geographic poverty trap. So what can you do about things like this? Well, my group has worked with folks in East Africa to develop rainfall insurance so you can immediately compensate people for herd losses. And it seems to be working. There's a bunch of impact evaluation evidence that shows this is indeed helping people to sustain herds, to recover quickly from droughts. But you also need to come up with other things that you can do, especially moving very poor people of small herds out of herding. So here's the index-based livestock insurance is the name of this project we developed with the International Livestock Research Institute based out of Kenya. And that has seemed to work quite well. Interestingly, when we do a relative performance evaluation, cash transfers introduced among the same populations by the Kenyan government in 2010, we can run a horse race, if you will, between cash transfers every month, poor people getting a small transfer versus giving them an insurance policy against drought. It turns out that the marginal benefit cost ratio of insurance programs in this setting is considerably higher than a cash transfer program, largely because you're leveraging the private sector. You subsidize the insurance, you pay to set it up, and then you turn it all over to the commercial insurers. All the risk here, 92% of the risk of these products is held by international reinsurers. You're taking drought risk in Kenya, you're moving it to Switzerland. And that seems to do a reasonably effective job of buffering people at relatively low cost relative to a cash transfer program. So let me switch to a different class of problems, but similar. Poor people who face real challenges, who will degrade the natural resources on which their future livelihoods depend, and this can trap them in poverty. We find soils are getting a lot of attention in Africa now because soil nutrient depletion amounts to something on the order of tens of billions of dollars of lost wealth in Africa every given year. We know that there exists, this is purely a correlation, and you shouldn't read too much into it, but we know that there exists a strong positive correlation between nutrient fluxes in soils, so how much nitrogen is lost, how much phosphorus is lost, how much potassium is lost, and per capita incomes in those same countries. So this plot just shows you a very simple correlation using data from a couple of different years. We don't understand all the mechanisms behind that, but we know that this has real consequences because we know two things. We know that soils that are depleted are less productive for cultivating crops or forage, and we know that soils that are depleted have lower stocks of essential minerals, so the crops that are grown are less nutritious for the humans who consume them. So depletion of zinc and depletion of other trace minerals that are really important, especially for young children, is a very serious challenge. So why do soils get depleted? Well, soils get depleted in part because people have no incentive to reinvest in their soils. So these are data that come from a bunch of soil tests that we did in Kenya combined with survey data on crop productivity. And the striking thing that you should take out of these two graphics is that on the left we show how soil organic matter, which is arguably the best summary statistic we have for soil quality, how soil organic matter maps into the marginal revenue product, if you will, the payoff from applying inorganic fertilizer, nitrogen fertilizer. And the striking thing here is that the 95% confidence interval on the payoff from fertilizer application is less than the cost of fertilizer up to a critical threshold of around 3% soil organic matter, after which point it becomes very robustly positive. So if your soils are sufficiently fertile, it pays to apply fertilizer in this system, and if they're not, it doesn't pay. Very simple. How does that correlate with household incomes? That's the right-hand side graphic. In the same sample, you find that in that lower tail where fertilizer investment isn't profitable for the farmer, those are the poorest households. The vertical axis in this case is per capita GDP, the per capita incomes of these households. Once you get up above the threshold where fertilizer pays, then people are above that rural poverty line depicted with the red horizontal dashed line. So we find that better off people are living on more fertile soils. They have incentive to reinvest in sustaining their soils, which maintains their productivity, maintains the health and nutritional status of their children, and they're able to maintain a good standard of living. It's a self-reinforcing feedback loop that keeps them out of poverty absent some terrible disaster hitting them. Conversely, people who are otherwise identical, living in the same communities, but start off with degraded soils for any of several reasons, have no incentive to invest in their soils. They mine them, they continue to deteriorate, their productivity is low, which further undermines their incentive to invest in their soils. So we see precisely the sort of separation that we saw among pastoralists that comes from range degradation and the behaviors around herding. In this case, it's behaviors around sustaining our soils. We're using fertilizer as an application, but it applies as well to investment in soil conservation structures, et cetera. So you see communities like this one in Madagascar, where on the valley bottom here, you see a very productive rice farm with a family that's doing quite well. And in the background, you can see as you move up the slopes of these hills, little patchworks of farms that are highly unproductive with very badly degraded soils. These communities, you're not talking here about a whole region that is poor. You're talking about people whose the only differences are what they happen to start with, what land they start with, the quality of the land, and the behaviors they engage in. And there are a lot of other things that go into the behaviors. We won't go there. I'm actually going to skip through this in interest of time, trying to tie these two together much more explicitly, especially around the now very popular concept of resilience in international development. My research group is working on some methods to actually formalize the concept of resilience and tie it to resource dynamics. Let me just skip through that. But just to wrap up, the power of Laudate Si, in my view, is the Pope's call for us to be in solidarity with the poor in recognizing how closely tied the poor's living conditions are to the natural environment, and our shared responsibility for both the fate of the poor and for the fate of the planet, and how we treat the planet impacts how we treat the poor. One of the things it misses is how the poor themselves have the power to affect the environment around them, and how the means by which we treat the poor can also affect the natural environment. We too often think of this as just generating pollution from our cars or from our electricity production. And oftentimes it's simpler things like, do we ensure there's a social protection, a safety net that catches very poor people so that they don't fall into behaviors that now degrade the environment on which they depend? This is a prime opportunity for very fruitful collaboration between natural scientists and economists. The key motivation from my perspective and what drew me into this was just witnessing the living conditions and the choices of extremely poor populations in places like rural Madagascar and Ethiopia and Kenya, and trying to understand why they were making these choices that were so obviously hurting their own children. Because they love their children the same way you and I do, and it's perplexing when you think about what will lead people to make these very conscious choices. So I look forward to the conversation. I thank you for your time and your interest.